In this section, we will learn how to graph piecewise defined functions and work with vertical and horizontal shifts. We start by working with a piecewise defined function. This function is made up of two halves. If x is less than 2, the function is y equals negative x plus 3. If x is greater than or equal to 2, the function is y equals 2x minus 3. For part A, we're looking for f of 0. Since 0 is less than 2, we use y equals negative x plus 3. For part C, we're looking for f of 5. Since 5 is greater than or equal to 2, we will using y equals 2x minus 3. I will let you work through the results of A through D. Let's move on to graph this function. To the left of x equals 2, the function is a line y equals negative x plus 3. To the right of 2 and including 2, the function is a line y equals 2x minus 3. What I'd like to do first is divide the graph at the value where the function splits into the two parts, which is at x equals 2. To the left of this line, I will need to have y equals negative x plus 3 graphed, and to the right, y equals 2x minus 3. So I start with the table of values. For the first piece, I pick values less than 2, also including 2. Now I can't include 2 with the first piece, since I must be less than 2, but I need to know what happens close to 2. So notice the comment of open for open circle. We will use an open circle when we cannot include a domain value like 2. As for the other part, I start with 2, which is included, and a couple other points. Notice closed next to that point. We will use a solid point to show a domain value is to be included. Here the points are plotted. The vertical line x equals 2 that I drew on the graph at the very beginning is not part of the function. See it as a line used only to assist me in graphing this function. You need to make sure these two lines or pieces do not ever overlap one another, since then this would not be a function. In the previous section, we took a look at the graph of y equals x squared. These two functions are shifted vertically by the constant added or subtracted from the x squared. For a horizontal shift, the constant will be, as I like to say, wrapped or bound with the x variable. Notice how for y equals x plus 4 squared, the shift is 4 to the left. I bet we would expect to see a horizontal shift of 4 right due to the plus sign. You can rewrite the function if you like. The shift is what is after the minus sign, or just assume that value but opposite the sign in the binomial. The second graph gives us a shift of 2 to the right. The sign of the leading coefficient dictates whether the graph opens up or opens down. Putting this all together, the first function opens up with a horizontal shift of 5 to the left and then a vertical shift of 6 down. The second function will open down. The graph is shifted 4 right and 2 down. We will talk about vertex and axis of symmetry later in this semester. Let's take a look at shifts in the nonlinear functions. The shifts will work in the same way as with the quadratic functions. For the first function, we have the absolute value function. The V-shaped graph will be moved off the origin 5 to the left and 7 down. The second and third function are radical or square root functions. Notice how the second function has the 5 under the radical with x, and the third function has the 2 outside the radical. The second function has a horizontal shift off the origin, while the third has a vertical shift. Here are the graphs of the functions that show the shifts. Thanks for listening. Hopefully this has been helpful.